This is the original cage grabber prototype where I basically based it off of a grappling hook and I decided that if I added some elasticity around this part of the grabber, it would be able to close back on itself after it was wedged open with this part right here. But after a few attempts of trying to use it, I realized it didn't really, it had too many breakable points. It was too complicated, and honestly, it could be better. And so then me and mentors were talking together, and we come along the idea that we could use basically just a kind of fixed kind of cage where the only moving part is actually um, these little pivots, little arm, I don't know what to call them, these arms that will basically move out of the way, and then they will also be elastic. And then when the pole gets here, they will shut back and basically, wrap around the pole itself. But we needed some way to stabilize the actual cage itself, so I made this little V-ish type shape that would basically, you know, uh, press against the lower part of the cage and kind of just keep it up, keep it upwards when we eventually rotate it at this point. Um, and then we basically decided and then I figured out that I would need to rotate it. And the first thing was I needed a point to rotate it at. So I added this hex shaft, and then these. Then we got to the point where we needed to attach the actual cage grabber to the robot. And originally we had to figure out how are we going to actually rotate this to the point where it would put the chain itself at the center, about the center of our gravity of our robot. And so I basically decided I'm gonna use hex tubes to actually like have our robot, and this should be I think about 18 inches from our base frame of the robot. I could be completely wrong. 14 inches from the 14 inches from the robot frame all the way up to the cage itself. And originally I went through ideas where we could use a kind of like a gear and a cog and a chain to be able to rotate it. But we went through the idea that it could put too much force here. So now we're going to use this as a just point of rotation, and we have plans to basically pull it from up here. And so originally I was going to use a linear actuator, but every time I would try and be able to get it to an angle where we'd be able to grab onto the chain and go back to this position, it would either be the linear actuator would be too long and it wouldn't be able to get to this point, or it wouldn't be long enough and wouldn't be able to get to this point. And so later on we decided we wanted to use a winch and constant force springs so that when the cage grabber itself isn't at is when it's like least stress is put on it, it'll want to be at this position, and then we'll have a winch that will basically grab and pull it to this position, and this is where it'll be in the most stress to be able to rotate the cage itself. And I went through a few iterations where I didn't, I'm still working on the actual winch itself, but this is the final area where we've gotten to. We're able to actually, think about how we're going to actually fully attach this to a robot. How we're going to do weight. We're going to have to balance out all the weight because we're going to have our elevator on this side. And so we're basically going to need to put as much weight on this side so that our center of balance can be as close to the middle as possible. But, this is where I've gotten to with this design so far. So in the past years, we basically had to, be hands-on, put something together. We would draw it out on like paper, but as far as, the actual designing process goes, we had an idea and then we just cut something and, got it together. And it worked. It was great. We did pretty well with that, mind aspect. But when we started using CAD, it allowed us to really design stuff out. Like you can see here that we have some weight reduction on a lot of these parts. So it allows our robot to be a little more complicated without all that extra weight. And then it allows us to actually design out, mechanisms like, this, where I was able to design out how I wanted to make maybe a grabbing mechanism and then change that quickly, easily, and a lot less cost effective because going from that, making that and then having to make this would be a lot more expensive if I went through multiple iterations of grabber mechanism. And so allowing me to test, also use joints to be able to test the motion of everything has also made this a lot more effective, so we know what won't work and what will work. And just all around makes our robot a lot better than it has been in past years, and possibly even maybe getting judge awards for CADing